I'm going to finish 6.1 today, and again, remember the difference here is it asks for an absolute extrema, and 99% of the time we'll be dealing with a closed interval. So remember that if you're dealing with a closed interval, you will only have one absolute maximum value or one absolute minimum value, but it can occur at more than one x value, so please be careful with that piece. When we're doing these problems, remember, we need to find our critical numbers. Make sure that those critical numbers are in my domain that they have defined. Find all of those pieces, and then we'll evaluate the endpoints and the critical numbers to see what is our maximum y value and our minimum y value. You have some extra examples on your handout that you can also use as well. So in class we did the first example, and so we're going to start with example 2. Key here, again, the difference is I don't have to do the first derivative test on these problems because I'm guaranteed on a closed interval that I will always have an absolute max or min as long as it's a closed interval. So we're going to start off first by finding our first derivative. So it should be x squared minus x minus 6. Again, this is my interval that I'm dealing with. So that's step 1. Step 2, find my critical numbers, set it equal to 0. There's nowhere that it doesn't exist. So I'm going to factor. So my critical numbers are 3 and negative 2. Both of these fall inside my interval that I have. So remember, again, step 3, we're going to now take, and I tend to like to do it in order, so I start with the smallest, and you can use your calculator, like I said, to do these and evaluate them, but I do want exact answers. So if you're getting a decimal answer, please make sure you use that fraction button to plug it in. So remember, we are plugging all of these back into the original function to find the y value that corresponds, and we are, like I said, just using my calculator. You will get a decimal here that repeats, so you do need to use that fraction key to get a negative 7/3 for the first. This one would actually, again, be a decimal that repeats. So I get 31/3. Negative 10.5. It's okay to put a decimal if it's an exact decimal and it's not rounding. So we now look at these answers and we look for the smallest value, and that's where, again, it also is helpful to still have that decimal approximation written down, because you should see that the negative 10.5 is the minimum, and then you should see, looking at the decimal values, the 10.333 is my maximum. So remember, how we write our answers is very important here. I have an absolute minimum of negative 10.5 at x equals 3, and I have an absolute maximum of 31/3 at x equals negative 2. You're using that fraction key on your calculator. Remember, it's not a difficult piece to use, so make sure you practice using it on your homework. So going to number 3, we're going to start it the exact same way. Here's my domain that we're looking at, my closed interval. So first step, find the first derivative. So 4x cubed minus 64x. Find my critical numbers, which means set it equal to 0. You can factor that using a difference of squares. So I get x equals 0, x equals 4, x equals negative 4. Look up at my domain. But again, that's why I think it's helpful to go ahead and list them in order. This would be f of negative 5, negative 4, f of 0, f of 4, and f of 6. And again, I'm going to calculate this using my calculator, plugging it back into the original function, because that's what's going to give me the max or min y value when I plug it back in. This is an endpoint. This is an endpoint. These three are critical numbers. Okay. So plugging in a -5 into that highlighted function, should get a -182, -263 when I plug in -4, a -7, -263, and 137. So I'm going to look at this piece and look for my, again, my max and my min. Notice that my minimum occurs at two different spots. I only have one value, but it occurs at two different x values. And then my maximum occurs at one spot. So I have an absolute minimum of -263 at x equals -4 and 4. I have an absolute maximum of 137 at x equals 6. Can always check my graph by plotting it in my calculator. That is okay, and I actually suggest it, but I need to see the work corresponding with this. So this whole work needs to be shown on your paper. Finding your critical numbers, evaluating your endpoints, and your critical numbers to determine it. But yes, you can absolutely use your calculator to check yourself. So going to number 4, we're going to now have to use the quotient rule on this one. Here's my interval. Low D high. Make sure you're careful with your signs. So I should get a -3 minus x. And over here I distribute that negative across. Be careful. -1 plus x. All over 3 plus x squared, quantity squared. So I'm going to collect my like terms. I should get a -4. The x's cancel. So here is my first derivative. So that was step 1. Step 2, find your critical numbers. The numerator will never equal 0, so I won't get any critical numbers from that. My denominator gives me x equals -3. But is that in my domain, my closed interval? Not in my interval. And honestly, it also is a restriction, because notice it was a restriction from the very beginning of this problem. So since it is not in there, I have no critical numbers to deal with. Step 3 just says evaluate your original function for the endpoints. So we will be always guaranteed a min or max because we will be including the endpoints. That's why that portion is so important. When you plug in 0 into this original function, you're going to get 1/3. When you plug in 3 into the original function, you will get a -2/6, which simplifies down to a -1/3. So we have an absolute minimum of -1/3 at x equals 3. We have an absolute maximum of +1/3 at x equals 0. Key again is I couldn't use that piece because it did not fall in my actual interval. Please double check that you know what you're doing. If you had done this graphically, this graph actually again has an asymptote at x equals -3. So it has a dotted line here, and it has a dotted line at x equals a -1, which is here. The graph looks like this. I might have my rough estimate there off, but notice I am only concerned with this interval here. Okay, so that's why my max and min occur at those two spots. So let's look at number 5. 5 has a natural log in it. So again, important piece to double check what we're dealing with. Remember, this has a domain rule that x had to be greater than 0, but that's not in the interval, so we don't have to worry about that. But that is an important piece to just keep reminding yourself. So my first derivative equals 2x minus 8. That would be 1 over x. Since I know I'm going to have to deal with solving this piece, I'm going to go ahead and get a common denominator, which would multiply that by x over x. So that's 2x squared minus 8 over x. So I just, again, multiplied to get that common denominator for that piece. So find my critical numbers. Again, where it's equal to 0, which is the numerator, and where it's undefined, which is when x, the denominator. X equals 0 is not in the in my interval, so I'm not going to worry about that one. I'm going to have a difference of squares here, which gives me an x plus 2 and an x minus 2, which gives me a 2 and a negative 2. Again, this one doesn't work because it's not in my interval. We're referring back, it has to be in this piece here. So now for step 3, we're going to evaluate at 1, at 2, and at 4. That's why, like I said, I like to do it in order from smallest to largest, because it also will catch if you've missed one of them that's not in the interval. So when you plug these back into the original function, into your calculator, and again, you can let it simplify it for you. Please read the directions on what they have. F of 1 will be 1. F of 2 will give you 4 minus 8 natural log of 2. That's the exact answer. The rounded answer would be negative 1.545. If I plug in 4, I'm going to get 16 minus 8 natural log of 4 for my exact answer and the rounded answer. So looking for my smallest is here, looking at my largest is here. So I have an absolute minimum of negative 1.545. If they want it exact, it'd be 4 minus 8 natural log of 2 at x equals 2, and an absolute max of 4.910. Exact would be 16 minus 8 natural log of 4 at x equals 4. That's my answer.